Okay, so area of a circle and sector. So again, what we just looked at this, but basically we do know how to solve for our circumference and our arc length. The circumference, again, of a circle is the distance around the entire circle, where arc length S is the distance between 2 points in a circle, and we're able to solve for our circumference or our arc length. We can also use these other equations. Either way, we can use these equations to solve for circumference or arc length. This one's circumference, and this one is arc length. Okay. So today we're going to get into first area of a circle. So the area of a circle is found by multiplying the square of the radius times pi. So basically our area of the circle is going to be the space inside the figure. So this entire area would be our area of the circle, the entire space inside that circle. All circles are similar because any full circle is measured by 360 degrees or 2 pi in radians measure. The area is only affected by the change in the radius. So basically, we can use the same equation to solve for area. The only thing that might change is our radius. Okay? And then just a quick reminder that our radius goes from the outside of the circle to the center. And so that is what our radius is. Okay? So say we wanted to solve this problem right here. This says a fountain with a circular base has a radius of 6 feet and is surrounded by a circular path that has a width of 2 feet. What is the total area occupied by the path alone? So basically, we want to find the total area, but we want to find the total area of this path alone. So we're not going to include the fountain part. Well, we can actually solve this very easily. Basically, what we're going to do is solve for the area of the entire circle, including the fountain, then solve for the area of just the fountain alone, and then subtract those two, and we'll be able to find only for the path. But the equation we're going to use, again, is area is equal to pi radius squared. Okay. So the first thing I'm going to do is solve for the entire circle. So I'm going to solve for both the fountain and the path. Well, if I need to solve for the fountain and the path, I need that entire radius. This radius is 2. So basically, I'm going to add those two radiuses together and see that my fountain and my path included have a radius of 8. So I'll do pi 8 squared. I plug that into my calculator, and I see that that's equal to 64 pi. Okay. Now I want to solve for just the area of my fountain alone. And the area of just my fountain, or the radius of just my fountain, is 6, right there. So pi 6 squared, which is 36 pi. Now what I can actually do is subtract these two areas together to find the area of the path alone, right? So the area of just the path is basically going to be 64 pi minus 36 pi. And that is 28 pi. And when I plug that into my calculator, it is approximately 87.96 feet in area. All right, so basically, if you have the radius, you can find the area of any circle using that equation, this equation right here. All right, does anyone have any questions here? Questions, concerns? Okay, now we're going to get into sector of a circle. So a sector of a circle is basically us having to find the area, but of us, like, just part of the circle. So we're not finding the area of the entire circle, we're just finding the area of that specific sector of the circle. A sector of a circle is the region of a circle bounded by 2 radii and 1 intercepted arc, right, which is pretty straightforward. Here we have our 2 radii. And here we have our intercepted arc. And so basically, the area of the sector would be that area that's shaded in. Okay. And so how do we solve for the area of a sector? Well, the area of a sector is found by multiplying these two factors, the ratio of the central angle over 360 degrees and the area of the entire circle. So basically, to find the area of a sector, when we have our central angle in degrees, we can use this equation right here. Remember that your central angle has to be in degrees for you to use this equation. So if we have our central angle in degrees, which we do here, we have 135. Basically, we can find the area of the sector. And if I wanted to solve for this one, I would just do 135 divided by 360 pi. What's our radius? 16 squared. Okay, I'm able to solve for that. Which is approximately 96 pi. So that would be my area of that sector. Again, this is you use this when your central angle is in degrees. When your central angle is not in degrees and rather it's in radians, as you can see, we have a much smaller, something that looks like a degree here. And so we know that may actually be radians. And so when you have your central angle in terms of radians, then what you want to do is just use this equation right here. And what you'll notice is the difference is you have your central angle in radians, and here you have 360, but in terms of radians. Remember that we learned that 360 degrees in radians is equal to 2 pi, where 180 degrees in radians is equal to pi. That was something we also looked at 8.5. So when it is in terms of radians, you use this type of equation for area of a sector. And basically, you just do the same thing. You just plug in your information. Okay, and you can actually cross these out. And so when you solve, you get 1.164. And so your answer is 70.4. That is the area of that sector. All right. Any questions about how to solve for area of a sector, whether it's degrees or whether it's in radians? Questions, concerns? No. So here's just another example problem. This one's asked, what is the area of the shaded sector created by the central angle, DOE? Here we see our central angle contains a pi, so it's probably in radians, or it is in radians. And so because it is in radians, we want to use the equation where we have our central angle over our radians of 360. And so basically you just plug in the information you're given. And so I can solve. This is 3 pi. The radius is 5. Now you can solve that. How do you solve this? Basically, just take the top part and multiply it by the bottom part. 25. When you do that, you get 3 pi. You can also just do this in the calculator. And when you solve for that, you get 75 pi over 8, or whatever you get in the calculator is also an acceptable answer. Okay? So basically, you know you have radians, so you want to use your radians area of a circle equation. You plug all the information you have in the central angle and the radius, and then solve. All right, any questions here? No? Okay. And so what did we look at today? We learned how to find the area of a circle. We find area of a circle by using this equation right here. This 2 is supposed to be over here. Sorry. Okay, so area equals pi over radius squared. That's how you find the area of a circle. And then to find the area of a sector, basically, if you have your central angle in degrees, then you want to use this equation right here. And then if you have your area in radians, then you want to use the equation that has this right here. Okay. Any questions? Questions? This one's pretty straightforward. You just take the information you have, plug it into the equations depending on whether you're looking for area of a circle or area of a sector, and solve. Okay. All right. We'll go over some example problems tomorrow, but if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.